Hi guys, today we are going to be working on synthetic substitution and the factor theorem. Just remember that in the previous sections we were working on solving polynomials using factoring, and the next couple of sections are going to be focused on solving polynomials that maybe aren't as easily factorable or maybe can't be factored at all. And so the methods that we're going to use in today's video and in the next section's video are going to be the theorems and the rules and the tricks that are going to help you solve those polynomials versus having to use all those different factoring methods that you learned in the last section. Alright, so if you have any questions, make sure you're asking as you go through the videos, but hopefully it will be pretty easy today. So, before we get started with the synthetic substitution, I just want to review the concept of that function notation that we learned in the previous chapters. I have this equation here. Find f of 5 when f of x equals 5x to the fourth minus 8x squared plus 2. Remember that function notation is just telling you what the x value is. So in that f of 5, that's saying you're going to plug 5 in for the x because it's inside the parentheses. All I have to do now is just write this down. I'm going to have 5 times 5 to the fourth minus 8 times 5 squared and then plus 2. Just go to simplifying in your calculator. So if you take 5 to the fourth, you get 625. So 5 times 625. And then minus 8 times 25 plus 2. Please remember when you're doing this by hand and showing your work, you always have to do the exponents first. That's very important. And then you can go ahead and do the multiplication. So 5 times 625 is 3,125. 8 times 25 is 200, and so we'd write minus 200, then plus 2. And then I want to go ahead and simplify that down to the very end, and I get that my final answer is when if I have f of 5, I get 2,927. And I'm done. So what that basically just means is when my x is 5, my y value is 2,927, and we're done. Now, that was just the normal plug and chug method. What we're doing today is the synthetic substitution. And so all you're going to do is use the same format of synthetic division that we learned a couple sections ago. And when you're done, you're going to be looking at the final answer at the end, the remainder. And I'm going to go ahead and set that up for you here. Remember, when you do synthetic division, you're going to make your box. And then in that box, you're going to have all of the coefficients. I'm going to underline those here, and the constant. And when I fill that in, I have 3, -6, +1, and then -11. And then for this in synthetic substitution, the number that's inside your notation here, that 3, is what's going to go on the outside. And then all you have to do is just remember the process of the synthetic division. You're going to bring down that first number, so in this case it's a 3, and then it's just multiplication and addition. 3 times 3 is 9. When I add those together, I get 3 again. Then I multiply. 3 times 3 is 9 again. Add 1 plus 9 and I get 10. And then 3 times 10 is 30. Add those together and I get positive 19. Now, normally we would take those numbers and we would write a new equation. But here, when I'm just wanting to know what the y value is, I'm wanting to find an answer, not an equation, I just have to look at that final number. So in this case, my final answer is 19. So when I write this in function notation, I write f of 3 equals 19. And you could check and see if that works. Take 3 and plug it into the original equation using the plug and chug method, and you should get 19, just like we did in the synthetic division. All right, so that process right there is called synthetic substitution. It's just like synthetic division. We just don't need an equation for our answer. We just need one number for our final answer. All right, hopefully that's pretty easy. If you have any questions or need me to clarify anything, let me know. But now we're going to work on the factor theorem. And the factor theorem is just taking this a little bit further. All the factor theorem says is that if you're given an equation, x minus r, that could be anything like x plus 5, it could be x minus 2, anything like this. It's saying it is a factor of a polynomial if, when you do synthetic division, the remainder is 0. You want to make sure you write this down. It's very important. All right, so we just have 2 examples, and then we're done with this section. The first example says, is x minus 3 a factor of the polynomial x cubed plus 4x squared minus 15x minus 18? If it is, find the remaining factors. So there's kind of 2 parts to this question. Well, in order to determine if it's a factor, we have to do the synthetic division. And so I'm going to go ahead and set this up. I have my coefficients in the front, or on the top, 1, 4, negative 15, and then negative 18. And then remember, when you're dealing with an equation here, you have to set that equal to 0. I want to write x minus 3 equals 0, and if I solve, I get x equals positive 3. And I'm going to put that positive 3 out on the front. Now, in the last example, notice there was no equation here. I just told you the number right away. So that is why I just put a positive 3 there. But when I'm giving you an equation, you actually have to solve it. And that's where I get the positive 3 in this case. Now let's do our synthetic division. Bring down the 1. So 3 times 1 is 3. Add those together. We get 7. 3 times 7 is 21. When I add those together, I'm going to get positive 6. And then I can go ahead and take 3 times 6, that's 18. Add those together, and I get 0. And remember, we just talked about the factor theorem. It says it is a factor if the remainder is 0. Well, here's my remainder. It's a 0. So it is a factor. So you could say x minus 3 is a factor. But then it says, if it is, find the remaining factors. What that means now is I need to use my solutions down at the bottom and write a new equation. Remember, when we divide, we drop down 1 degree. So this equation is going to be x squared plus 7x plus 6. And now I just need to look and see if I can factor this equation here. Well, what are my factors of 6 that can multiply to get 6 but add to get positive 7? I'm going to make my parentheses because this is just a quadratic. So I'm going to have an x and an x here. And then my factors of 6 would be a 6 and a 1. 6 plus 1 is 7, and 6 times 1 is 6, with 2 signs that are both positive. And so my final factors here are x minus 3, and then x plus 6, and x plus 1. So when it's said to find the remaining factors, these are my 3 factors, and then I'm finished. So look and notice that in this case, I was able to find 1 factor, or they were giving me 1 factor, and then I could do my synthetic division, and that helped me factor the rest of the polynomial.